So now we are going to solve problem next greater numerically balanced number. So what is the problem stating? It is a medium period lead code problem. So an integer x is numerically balanced if every digit d in the number x, there are exactly d occurrences of digit in x. Given an integer n, return the smallest numerically balanced number strictly greater than n. So the problem is stating that a numerically balanced is a number in which there is there is a digit d, so it should have d occurrences. Means ki number of occurrence should be equal to the number of the value of digit. So we have given an n, and for that n we have to return the smallest numerically balanced number. That means the smallest numerically balanced number which is greater than n. Let me show you an example. Suppose n is equal to 1. So if you will check that what is the number, 1 can be seen only one time. So if we use 1, it will be a balanced number. Now if you want to say that yeah, well, then you use 1 and 2. So what will happen? 1, 2 and 2 should appear 2 times. So 1, 2, 2. So it will be greater than 22. We have to find the smallest numerically balanced number. But if we take 2, so it will be 2, 2. So hence the answer is 2, 2 is because 2 appears 2 times. So for this problem, uh, n max n that can be given input is 10 to the power 6. So if n is 10 to the power 6, let us take what can be the output for that. If n is 10 to the power 6, the smallest which is possible, 1 time, 2 2 time, and 4 4 time. Basically it is an observation. If you will check, then it is any other number is not possible, which is for 10 to the power 6, which is less than this and is beautiful. So we can basically it is we can iterate a loop till here because it will be a max possible answer. So we can iterate a loop till here and we can easily solve. So what we are doing here is we have made a vector of count. So we are iterating. We have been given an x, while x. So what we have done, we have basically stored the it is a function which checks whether the number is beautiful or not. So when the x is passed, a counter, the array is made for the digits, counting digits, and we are taking the where till the x is not 0. So what we are doing, we are taking the modulo when it's the last digit, we are increasing its count, and x is reduced to x by 10. So now uh, we have counted number of digits. So now we are checking if the number of if that digit is particularly available. Count of I is not equal to 0, and count of I is not equal to I. Then return false, or return true. So for every number, it checks whether it is beautiful or not. So it hardly takes the number of operations which it takes in O of number of digits. So how we use it here? While true, if is beautiful x we have been given n, so we need a number greater than strictly greater than n. So I have started from n plus 1. If it is beautiful, then we have to return it. Otherwise, keep on increasing. It will maximum go till 1 2 2 4 4 4. 4 times 4 till this number. So we can easily do it in O of 1 n and return minus 1. So as we have to return something is at last, but this case will never reach. So it is just a dummy case. So that's it.